Hi, welcome to problem 17 on page 276. The first thing I'm going to do here is take the first derivative, which means I'm going to follow the quotient rule. I'm going to square the bottom. Now it'll be raised to the fourth power. I'm going to copy the bottom equation down. Times the derivative of the top, which would be just simply 1, so I don't really need to write anything, minus the derivative of the bottom. Now when I do the derivative of the bottom, I have to do the old chain rule. So it's going to be 2x squared minus 1x, or just minus x, plus 1 to the first power. Derivative of the inside is 2x minus 1, and times the top, which would be x minus 2. All right, now what we can do here is we can factor out. We see that there's a common factor thing here. So I'm going to go to the yellow. We say that this is the same as this is the same as this. Well, down here I have 4 of these guys, right? And on the top I have 2, and then on the top I have 1. Well, I can factor out one of them. So what happens is that's going to make one of those disappear. So my final answer on the top would be x squared minus x plus 1 minus 2. Then that yellow thing goes away, and it's going to be 2x minus 1, and then x minus 2, all over x squared minus x plus 1 to the third power. So see, one of them disappeared in each part. So it's now one of them, none of them, and 3 of them on the bottom. All right, I made an extra dot there by accident, so I got to erase my dot. There we go. Okay, continuing on. I need to multiply the top out. That's easier said than done here, isn't it? So I'm going to just focus on the top right now. X squared minus x plus 1. Now I'm going to leave the 2 right there, and I'm going to start doing FOIL. 2x times x is 2x squared. 2x times the 2 would be minus 4x minus 1x plus 2 all over. Copy the bottom down. X squared minus x plus 1 cubed. All right. Keep working down the page. This is not easy to do. All right. Distribute the negative 2. This, however, is negative 5 right there, negative 5x. So when I distribute that, I'm going to make it positive 10. So we get x squared minus x plus 1 minus 4x squared. That's the negative 5 times the negative 2. See, I'm distributing here through the parentheses. And then I get positive 10x minus 4 all over, copy down, x squared minus x plus 1 cubed. Still working on the first derivative, mind you. Now I simplify the top. I get negative 3x squared. Then I get plus 9x minus 3 all over x squared minus x plus 1 cubed. Now let me match that up to my notes here that I have. I have 3x squared plus 9x minus 3, and that is over x squared minus x plus 1. That is the correct first derivative. Now, what you have to do at this point is you have to take the first derivative and you have to set it equal to 0, because we want to know when the intervals of increase and decrease are. Okay? You also need to think about when the bottom is set equal to 0. I'm not sure whether the bottom is ever equal to 0. I think you just have to worry about the top. How could we figure out whether the bottom was ever equal to 0? Well, you could just focus on the inside part here. Is x squared minus x plus 1, is that ever equal to 0? That's the question mark, and that's the question. If we go to the graphing part of the the calculator here. There's my virtual calculator. I can type in into the, turn it on first, type into the equation editor here, x squared minus x plus 1, and then delete everything else that was there, and then graph it. This is a positive parabola. It has no negative values, so it can't be 0. So we are lucky in this problem. All we really have to do is just worry about the top of the equation. When is the top of the equation equal to 0? We don't have to worry about the bottom on this one. So I'm going to back up this stuff here, make that go away. So when is the top equal to 0? The only way to solve this is with the quadratic formula, and I'm going to let you do that on your own, but this derivative is really tricky to get. So what you need to do now is you need to do the quadratic formula, okay, and then you need to make the sign chart. Once you do that, quadratic formula and sign chart, once you do that, then you'll know the intervals of increase and decrease, okay? And you have to use the quadratic formula because this does not factor on the top. All right. When you do the quadratic formula, you might change the -3 to a +3, like run a negative through there and change it. Like this is what I mean. You have -3x squared plus 9x minus 3 equals 0. Well, there's two negatives there. Let's make it one negative by running a negative sign through here. So we get 3x squared minus 9x plus 3 is equal to 0. Now make A equal to 3, B equal to -9, and C equal to +3. Then do your quadratic formula and make your sign chart. Okay, I'll let you do that on your own. Moving right along.